Hello everybody, my name's Simon Timpley from the International Food Safety and Quality Network. I'd like to welcome you to edition 43 of the Food Safety Fridays webinar programme. Today I'm delighted to have our friend Yasser Mustafa Mohammed, back Quality and Food Safety Manager at Mars, back for another presentation. Today we're going to be taking a trip through history to look at quality, how it's evolved through the last 100 years or so. Has anybody driven a Model T Ford car? Anybody on the webinar has driven a Model T Ford car? Maybe not. Or a Ferrari. Well, we're going to talk about how we build quality into products, and from the early days, mass manufacturing and the need for standardization and efficiency, right through present day and the proliferation of standards that we all know and love. I'd like to thank the sponsors who bring these webinars free of charge to you every week: Safe Food 360, Metal of Toledo, Trace Analytics, and FSSC 22000. They help to bring these to you free of charge, and you get a free certificate of attendance. So can't say fairer than that. We'll just head over to Yasser now to say a quick hello.
Hello.
Hi, Yasser.
Yeah, fine.
Good to have
good.
you with us again.
Yeah, good.
Are you okay?
Thank you. Yeah, I'm okay. Thank you.
Who's that in the background?
Yeah, yeah. It's actually I put a lot of things on the cartons because I'm moving to another home. So that's
right.
all right.
Very
So
nice.
I'll start. Yeah.
Yeah. If you get your presentation ready, Yasser, I'll just talk about next week's webinar.
Okay.
Okay, ladies and gents, if you look in this sidebar, you'll see a picture of David Rosenblatt there, and the title of next week's webinar is How ISO 9001:2015 Can Improve Your Food Safety Management System. David says that the new version of ISO 9001 represents a fresh approach to managing quality and can be integrated with the organization's food safety management system more effectively. So in this lecture next week, David will be telling us about the major changes in the standard and ways to take advantage of them for the benefit of improving our food safety management system. So that should be good. David's a great presenter. He's done a couple for us in the past, so I'm no doubt that will be very enjoyable. Even if you don't use ISO 9001, I'm sure you'll get something out of it, as we do every week. Okay, without further ado, before we move on to the presentation, today's webinar is being recorded, as it is every week. Within 24 hours, we send an email to all of you registrants with the link to the video recording, the slides, the certificate, and the follow-up discussion. Everything gets put in that email. So please wait for that email. If you don't receive the email, check your spam box before you email me. That will help reduce my administration. That's all from me for now. I'll be back for the Q&A later, but for now we'll go over to Yasser. Okay, Yasser?
Okay. Yes, I'm okay. All right.
Ready to go.
Yeah. Hello, everybody. Today, our seminar it's related to the chronology of quality, the history of quality. And I'm always telling on myself, we cannot work as in a quality field or in a food safety field until we need to have the knowledge and history of the quality itself. So at least we will see the sequence of the quality from beginning till the end of the day. So definitely we will learn from a lot of it, how we can get some benefits from all of the trials and from all of the history of the quality itself globally. Right. Our contents today, it will be in two parts. Actually, the presentation today is a little bit long. It's around maybe 66 slides. So we will need to hurry for some slides because a lot of text we can find it. So the contents in the two parts. The part one is the history of managing of quality, rise of statistical methods, quality and World War II, post-war developments in quality, Kaoru Ishikawa and quality circles, in search of zero defects. We will learn what our quality guru they start to do for the quality inside their factories. In the part two, we will find a beginning of the quality crisis. US discovers quality and quality gurus, quality and Six Sigma and awards, certifications, standards, and finally the conclusion. All right, so we'll start our presentation. It's like a story. I hope that it will be a nice story and will be beneficial for everyone. We'll start by the history of managing for quality. Joseph Juran, which is the godfather for the quality. I think everyone he knows about Joseph Juran. He traced the history of quality management back to the time when the pyramids were built in Egypt, as definitely the ancient Egyptians, they start to build the pyramids in a quality standard, in a geometrical system. So in order to keep for a long thousand years, so they start even know about the quality from many thousand years. Then let's go to the Industrial Revolution. However, until the advent of the Industrial Revolution, there are some mass production also appeared. And due to the mass production, quality management involved little more than craftsmen checking their own work. So it's only the craftsman, when he's doing or producing some of his products, he need only to inspect the final product in order to check the quality and in order to sell his product. The need for the quality in the production of parts increased when the US system of manufacturing required parts to be produced exactly, and they are they are influenced. The American people, they are influenced by a general, what we call French general, Jean-Baptiste de Gribeauval, who attempted to standardize parts in the French arms industry in 1765. So the US government and the US War Department, they got most of the quality system from the French people during this time. And they start also to encourage the mechanization at federal arsenals. And I want to just inform that the quality system on the beginning, it's coming from the military part or military area. And finally, it's this system, what we call the American system of manufacturing. This is the most or the first beginning system for the quality and for the manufacturing itself. Then we'll start by the rise of statistical methods in quality. It's very important, by the way. I'm always telling that the quality manager, he needs 3 skills. It's very important. He needs to have a managerial skills, technical skills, and statistical skills, which is the most important part of the skills for any quality manager. So the rise of statistical methods, it's began on the Western Electrical Company, Hawthorne plant, which is a division of AT&T. Hawthorne plant, it's an electrical and telecommunication company. It's a very huge and very big. And they start to have like what we call a mass production. And they start to put an inspectors to check and to inspect the product itself as a final product. The plant itself was made famous in industrial psychology because of Hawthorne experiments, which determined that employees work better when they feel that management has taken an interest in them. I think maybe many people, they knows about Hawthorne experiments. Hawthorne experiments, it's very simple. Some people inside this plant, they start to check the employees, what kind of motivation the employees they can get in order to produce more and more in efficiency with effectiveness. So they found some people, they found that the motivation is money. Some people, they found that the management, if the management make more and focus and interest on employees, then they will start to produce more and more. So this is mainly the Hawthorne experiments. This is the factory itself, actually, and it's very huge, as we saw in the picture. From then we go to the inspection problems. Juran worked at that department. By the way, most of the quality gurus that's found all over the world, it's coming more and more experiments in the Hawthorne plant. So the Hawthorne plant is like the source of quality gurus all over the world. So Juran, he's worked as a department around the time when it was attempting to scientifically determine optimal sampling plan. Joseph Juran, as we said, he's like a godfather for the quality itself, and he's working on the sampling plans long time in this Hawthorne plant. However, there are a lot of weaknesses in Hawthorne plants, reliance on inspection. Definitely, The waste was created from producing defective products because they only checking the final product. Production workers didn't have a say in controlling their own work. There is no any like a quality system there. Inspection gauges sorted good product from bad without providing feedback about the process. So just only they inspect, they reject, and they are not reviewing the performance of the process itself. Sampling tolerated only a specific percentage of defective parts. Inspectors also were not capable of detecting 100% of defective because they are not checking every part of the, or they are not inspecting every part of the product. Another problem also, because there are a lot of defective parts, it can be found during the inspection. So finally, it will raise the cost of producing the parts, which it will affect the customer as an end or as a final customer. And the last one, the last point for the inspection problem, the cost for inspection itself would be also a factor that could drive up the cost of finished products. So finally, it will have a problems as a cost, financially, quality, and finally, it will not satisfy our customers. So Juran, he started in the Hawthorne plant, 5,200 workers out of 40,000 were employed in the inspection department. So see how huge number of inspectors against the final number of the workers itself. So this is definitely it's giving a high cost, and finally it will affect the product sales and the product profit itself. All right, then you start to think for another idea. It's like what we call a quality control. There is one person, his name is Harold Dodge. He started as a development engineer in 1917. He explained that during this early 1920, industry was attempting to work scientifically using Frederick Insel Taylor's theory of scientific management. I don't know, some people, they know also about the scientific management and the Taylor theory. Scientific and management, Taylor say they are having four main principles. So we'll discuss it maybe later. But this is mostly for the as a management system or as a management tools. How can they deal with the workers? How can we deal with the employees themselves? And they are using such tool like Gantt charts, which is mainly they are using for many projects. At this time, industry was trying to strike a balance between cost, schedules, and quality. And finally, they start to make an equation with a new factor, and the new management methods become known as a quality control. So they want to just make a balance. They want to check if the product is in a good quality, and finally also it's achieving the target cost that we need to achieve it. Many techniques such as sampling plan and statistical process control, which is the SPC, were soon being referred to as statistical quality control. So this is the main or the first beginning of the SQC, which is a statistical quality control. They start to look as a quality control using the Gantt charts and using the Taylor theory of scientific management. The quality control rise with Western Electric. In 1924, Bell Labs is owned by Western Electric, used 100% testing and inspection. So every parts, every product, 100% should be tested and inspected to determine if products were in conformance with requirements, and many products were reworked so they would function correctly. The risk of having material rejected influenced producer to improve their quality, and finally, the results as an inspection will decrease as amount of samples increase. Inspector received better training, measurement, and accuracy was improved. So it's like a kind of improvement, or like a kind of raising the role of the quality control itself in Western Electric. Then they start to use the control chart. Walter Shivert is one of the engineers at Bell Labs. He created the control chart in 1924. Control chart, it's they are checking two things. They are checking the process, either stable or not stable. And finally, the product is within the specification limits or not. So they are checking both together, the process and product, by using the upper and lower control limit. And again, if there is an unstable process, it would be a signal for the operator to check the machine that produces the parts. Maybe the machine problem, maybe the process, maybe the input itself or the incoming material itself that they have a problem. So all of this, he need to check based on the control charts that it's found or that's finally as an output for the process itself. Then Sheward's control charts took many years to be implemented on Hawthorne plant. Joran reports he tried to encourage managers to use the charts, but seldom succeeded. Why? Because most of the people, they think that they need to ship the products, they need to produce, and finally, they don't want to go through the process and product performance and all of this. And even the workers got bonuses based on piece rate system, definitely. If how many pieces you will get, so how many pounds you will get or how many dollars you will get as an incentive for the people to produce much product as possible. Then they are seeking for another area or another point of improvement. In 1925, Bell Labs Inspection Engineering Department and Hawthorne Inspection Branch formed the Joint Committee on Inspection, Statistics, and Economy. The Hawthorne plant started as a new department called Inspection Statistical Department. This is the first time that they start to think about the sampling plan. How can they will do this sampling plan? How many samples they need to get it based on the process and on the criticality of the product itself. So statistically, the sampling plans made based on production lots, and each lot was permitted to have a specific percentage classified as a defective. A single random sample was used to determine if the lot should be accepted or rejected. The rise of statistical methods again in 1926, Joran realized that there is no defective parts in the lot if the production process was perfect. We are all definitely accept this statement. But there are something else also. No defective parts also in the lot if the process was very bad. How can this? All right, because defects would be found during random sample and the entire lot would be 100% inspected. So it's meaning that also because we are taking a random samples and we are using 100% inspection, finally, we are ensuring that the product will be have no any defects at the end of the process itself. However, if the process was somewhere between the two extremes, it's what we call the average outgoing quality level. What's the meaning of average outgoing quality level? There is like two limits or two upper and lower control limits, and they need to check the product itself as a quality. What is the maximum or what is the acceptable quality level of the product itself? So based on the maximum acceptable quality level of the product, they start to look for the process. If something little bit deviated or higher deviations or whatever, so they will start to measure and check if the product and process will be really satisfying the customer and even matching the quality level or not. And definitely also they need to check, they are like make comparison between the incoming goods and the outgoing itself. The incoming goods as a quality is the same like outgoing quality or not. And based on this also, they start to make like what we call a process performance measurement. The Hawthorne plant sampling plans were eventually issued in US government standard called Military Standard 105A, which is, this is the main, the first page of the military standard. This is related to sampling procedures and tables for inspection by attributes. All right. The rise of statistical methods in 1931, Sheward published Economic Control of Quality of Manufactured Product. I already always put like an blue highlight and underline for all of the main basic books for the quality. This is very important, by the way, and this is like the infrastructure of the quality. You can even download it over the internet, and a lot of times I read for such books. Really, it's adding value. So even some people, they can also check these books over the internet. When he published this, it's edited by William Edward Deming. Definitely, most of them know about William Edward Deming, which is the main person for the PDCA, Plan, Do, Check Act. Sheward started lecturing on the use of statistics using the field of quality. And Sheward's 1938 lectures at U.S. Department for Agriculture become the basis for his book, Statistical Method from the Viewpoint of Quality Control. Right. So now we know about the statistical process control, and we know about the Shivert, and he start to do statistical tools, or start to using statistical tools, and he start also to train and to even teach for the U.S. government and military based on the sampling plan that he have it in after edition from William Edward Stemming. All right. So both of them, they are working in Hawthorne plan, as we mentioned before. Right. Then we'll start to go for the third part, the quality and World War II. Right. We know about World War II. It's 1939 till 45. And before start to follow War II, Sheward advised Simon of the Pentagon's Ordnance Department. Ordnance Department, this is related to the weapons manufacturing department, to use statistical methods. And the Ordnance Department decided it must either train all suppliers in statistical process control, or must implement acceptance sampling. So finally, they chose the acceptance sampling because of the large amount of material that was needed in a short period of time. So because training for suppliers, for SPC and all of this, it will take time, and it will not get more benefits rather than to go for the acceptance sampling. All right, for the SPC, during the early 1940, Deming recommended that Stanford University statistics teach SPC. Juran explained that the War Production Board assigned university statistics professors the task of training government contractors in the use of Shivert's control chart. The main effect of these classes was the rise of quality engineers and quality managers within the factories. So when they start to teach for the people about the SPC, why I'm telling the statistical sales is very important. It's one of the main three skills for any quality managers, because we cannot transfer the information or transfer the data into valuable information that we can finally measure the process and measure the control charts or the deviations that we can find it in the product or the process itself. So if I'm not having this SPC skills or techniques, I cannot measure the process, I cannot get an added value to the company itself. And finally, I'm just only working as like an inspection and managing without adding a real and more beneficial value for the company itself or the factory. So based on this, the quality engineers and managers, they start to develop a quality departments within many manufacturing companies. There were other breakthroughs in quality during World War II, but most related to inspection and sampling techniques. So till now, we start by inspection, sampling, and we go for the SPC, statistical process control. Right. So at the time, the emphasis was on technical solutions to quality problems, and there was little worker involvement. So most of these techniques used by supervisors, managers, but worker involvement is very less. So the main objective was to meet delivery schedules, and quality came second to that goal. So still now, the quality is not number one during manufacturing. Again, even after the SPC usage and SPC training. All right. For the SPC, some progress were made in using statistics during World War II. A U.S. government report on industrial research, how useful statistics were in purchasing munitions. Munitions is like all of the weapons and of the military equipments. And the report notes that the days when engineers considered mathematicians to be strange and incompetent had ended. So I'm not also telling that I should be a mathematician to know about the SPC, but any person, they can learn about the statistical process control, which is very simple learning tools, which it can add value to us. The report was also refer to Shivert's statistical methods from the viewpoint of quality control, which we mentioned before, and quoted by Juran, who explained that inspection both removes defects parts and alerts the manufacturer to the existence of a problem. All right. In 1947, report from the National Academy of Science explained that the statistical methods were not well known in industry outside of Bell Telephone. Bell Telephone, it's as we mentioned, it's a branch of Hawthorne plant that related to AT&T. However, many companies quickly started using statistics for accepting or rejecting deliveries based on statistical sampling. The report was intended to be distributed to all organizations to teach the statistics, and according to the report itself, the board started teaching statistical process control for production people and engineers in 1947, and about 2,000 people from more than 800 companies attended the training class. This is the first widespread usage of statistical process control over the board. So I think 1947 this is the main and the first beginning years of using widely for the SPC itself. All right. In his A History of Managing for Quality, this is also one of the reference book that Juran, he explained on it. Many companies stopped using SPC after World War II. Why? Because companies didn't think it was economical, because they are checking everything in a few percentage. There was also a shortage of consumer goods at the end of the war. This definitely after World War II. And meeting delivery schedules took priority over quality. So they want to ship, they want to make a mass production with less cost, and finally the market they need because they don't have any consumer goods or very short in consumer goods. So some of the new quality engineers participate in quality planning, wrote reports, manuals, procedures, audits. Some companies created quality control departments run by managers who had in charge of the formal inspection departments. Around this time, quality departments began to be placed under management in organizational diagrams. All right, post-war developments in quality. So now we discuss about the history, then the pre-war, then we go now to the post-war itself. After the end of World War II, US industry had become a seller's market, and the priority for manufacturers was quantity over quality. So this is a start of the main US mass production related to the product itself, and they are putting a priority of the quantity rather than quality, and many companies discontinued to use the statistical process control. This is always very bad. And even AT&T abandoned Shivers control charts during the 1950s. Business schools at this time also thought that increased quality was the equivalent of increased cost. And this theory, together with the seller's market, lowered the quality standard in US industry. So believe me, some companies right till now, they are thinking that if you are doing a quality system, finally it will increase the cost. See, this theory is from 1950, which is more than 50 or maybe around 60 years right now. So this theory is very, very old, and this is totally not right. Then on 1946, ASQC Formation, which is related to American Society for Quality, Preston Westcott, who had been one of the war production board, got together with George DeForest Edwards, Bell Labs Director of Quality Assurance, and 8 other men to start to build an American Society for Quality Control. The new society was merging of 17 different quality societies and originally had 253 founding members. By end of 1946, there are more than 1,000 members, and become the first annual convention in June 1947. Because some people, they are members in the ASQ. This is the first start of the ASQ, American Society for Quality. And it's also at this time, Walter Shivert, a founding member, was voted in an honorary member, and Society Shivert's Medal was created, and dropped the word control from its name in 1997. So they are putting American Society for Quality Control, but on 1997, they dropped the control itself. All right, now we'll go to Japan quality rights. Now, we mentioned that in US, they start to look for the mass production. They start to go for the piece rate system and for the quantity over the quality. They are not using, or they drop using of statistical process control. And finally, they only want to ship the product as per the delivery and the schedule itself. Right. As US quality was declining during the post-war selling frenzy, Japan was struggling to rebuild after the devastation of World War II. Also, the Japanese were capable of producing high-quality war machines. The country had a reputation in West for low-quality goods. Japan had very few natural resources and realized it needed to produce quality goods to build an export market. So these people, they don't have much natural resources, and they want to compete, they want to sell their products, they want to rebuild again their factories, so they will start to look for the quality for their factories. In early 1946, General Douglas MacArthur asked a radio engineer named Homer Sarason to go to Japan to help rebuild the country's war-torn radio industry. MacArthur wanted to broadcast to Japanese households, but factories, unfortunately, had been bombed during the war and couldn't produce radio receivers, and most of their upper managers had been killed or jailed. So they don't have the facilities, they don't have even the resource or the management resources. So MacArthur ordered that training should be conducted to remedy this by training the people themselves. And Charles Brotzmann arrived to help Sarason in 1948, and together they prepared the textbook, The Principles of Industrial Management. This is one of the best book for the industrial management. And it's still now a lot of people, they look on it and they got a lot of experience from reading such a book, which they use to train managers in manufacturing and mass production. The textbook also contains a section on quality control, which some Americans objected to because they feared it would make Japan too much of a competitive threat. So definitely they don't want to have competitors. In 1950, Sarason invited William Edward Deming, this is the pacemaker for the quality in Japan, William Edward Deming, to teach statistical process control in Japan. Deming introduced the Japanese to Joseph Juran. This is the second pacemaker for the quality in Japan. In his book as a quality control handbook, the Japanese eventually invited Juran to Japan to teach them about quality. So Deming started to teach from the Juran book, and definitely the Japanese people, they invite Juran to come and make more and more training to them. Deming was invited to lecture on ASQC, Statistical Quality Control, by Union of Japanese Scientists, and 3 years after the group started working with quality control. This is Juran's quality handbook. This is the main source of the quality all over the world, and it's a very big book actually, and there are a lot of informations inside it. And I prefer that everyone working the quality, he need to have this book. You can also find it over the internet. So at least you start to look for the quality control, quality assurance, and standards and everything. You can find it in this quality handbook. It's like a reference for the quality for anyone working in the quality field. All right. Many people credit Juran and Deming with improving the quality of Japanese products. However, Juran believes that Japanese quality revolution was the most important thing to be happen after World War II, definitely, and that it would have happened even if he and Deming had not gone to Japan. So he said that it will happen even if he will not go to Japan with Deming. And during his lectures, Deming went beyond just teaching statistics and explained the Plan Do Check Act production cycle to Japanese managers. We all know about the Plan Do Check Act. It's a tool to ensure the customer's wants and needs are considered throughout the production of a product. The 4 steps is beginning during the product design, which is on the plan itself, and are repeated throughout the product's manufacturing. And General Motors during this time used to design a vehicle and then rely on sales pitches and advertising to sell it. So they start to design the product, and after designing and finalizing the product, they start to make an advertisement about their main features of the product itself, which is comparatively to PDCA usage, is not right or is not successfully implemented, because company using Plan Do Check Act will study what customers really want and design a product that meets these needs using Plan Do Check Act, which is helping Japan design and build products based on customer requirements. So on the Plan Do Check Act, they are looking for the customer requirements, customer needs and expectations, and based on it, they design the product itself. and they start to make it in a small pilot project, and they need to check if it's successfully meet the criteria for the standard criteria of system, and they start to implement for the whole project itself or for the whole production facility. The management responsibility in the New Economics, which is also published by William Edward Deming. Deming places a responsibility for quality on management's shoulders rather than workers, and stating that workers can only try to do the job. So many people, they think that the workers, they are responsible for the quality. No, definitely the managers, they are main responsible for the quality, and they should carry on their shoulders for any responsibility related to the quality itself. Job security and jobs are dependent on management foresight to design product and services that will also interest customers and build a market. Kaoru Ishikawa and quality circles. Kaoru Ishikawa is one of the quality guru in Japan, and he explained that the quality control places an emphasis only on inspection. The only one department within a company is involved. So if I'm only focus on inspection, so I will involve only one department. However, if I will look for the manufacturing process and involving a lot of departments like to assembly lines, subcontractors, divisions of purchasing, production, engineering, and marketing, definitely we will prevent any defective products to be shipped to the customer. Kaoru Ishikawa worked as a production engineer at Nissan, and he joined the quality control research group of Union of Japanese, and he believed that Plan Do Check Act was the most important part of the quality improvement, as that process needed to be controlled to control product quality. Ishikawa, in What is Quality Control, this is his also a published book related to him, explained that all divisions within a company should be involved in quality control. And he also says that workers and foremen must be good at what they do in order for quality control to function. However, it was not easy to educate workers and foremen in Japan during late 1950 to address this problem. So Japan Broadcasting Corporation aired programs aimed at introducing quality control to workers. So in order to have quality circles or need to have decisions came from the workers, who need to have a qualified workers. So he will start to train the workers on the quality control. It's not to just train them how they will produce, how they will manufacturing as a production or operation. No, it's very important to also train against the quality control itself. Supervisors asked for their own quality related to journal. So they want to be separate from the workers, but he worried that many supervisors would not read the journal, so he advocated quality circles. This is the first main idea of how they build the quality circles. Quality circles, it's very simply, as I mentioned, it's a group of workers or employees, and this group, they start to solve any problems operationally or inside the production by themselves. And after solving the problems, they need to implement also by themselves and check the process if it is okay or not. So they are not depending on supervisors or managements or managers, but they are depending about the worker or the person that is doing the work itself. This is what we call a quality circles. There are a lot of companies, actually, even in my company right now, we are doing this quality circles. That's every day morning. The workers, they have a small short meeting, and they start to seek for the yesterday problems, and they start to look how can they will prevent this and how can they will apply the improvements or how they apply the solution on the same day or the next production, right? So quality circles are to be organized on a voluntary basis from the bottom up and not top down, and they are form of a democratic management. Many US managers went to Japan to witness quality circles in action, but failed, unfortunately, to notice that they were just one part of a bigger picture. So the US people, they think that the quality circuits, this is the main quality tools that Japan people, they start to use. But definitely it's a part of the main quality picture for Japan. It's a part of the system. So Japanese companies use quality circles, also had engineers and managers working on quality problems and problem prevention, but the visiting US managers failed to notice this. In his autobiography, Architect of Quality, Jonan observes that quality circles did produce spectacular results, but they were part of an overall system. So we cannot put all of our quality efforts on only the circles. It's a part of the system itself, and not the single cause of quality in Japanese products. American use of quality circles increased dramatically during the early 1980s and then quickly declined. Also, some circles were still going into the 1990s. The quality circles that did survive did so in a changed form. Right. Quality is free. While Japan was organizing quality circles, the United States started the zero defects movement based on the writings of Philip B. Crosby. Philip B. Crosby is a person. He's an engineer person, and he started to look on his book as a quality is free about two main issues. First, the lack of knowledge and lack of attention. He believes that lack of knowledge can be corrected through proven methods, and lack of attention require a person to reappraise his morals because he has an attitude problem. So he needs to work on the knowledge and on the behavior of the person itself. Crosby proposed that simply paying attention is a major step on the way to achieving a zero defect. He also said that management must inform workers of the need for a zero defects mindset, and claimed that 85% of all problems can be solved by immediate supervisor. And remaining 15%, 13 can be solved within next two levels of supervisors or departments. So 85% from the supervisor can be solved, and we can put the lower rate to some other problems or issues can be going to the employees or whatever. So this meaning that the managers and supervisors have a big role on this. Right. In search of zero defects, Kaoru Ishikawa recalls observing the zero defect movement firsthand. By the way, for the zero, I want to just go back for the zero defects here. He mentioned that that it would be failed because it was a movement without tools and become a movement of mere will. That emphasized that if everybody did his best, there would be no defects. Ishikawa added that the US was heavily influenced by Taylorism. You know Taylorism, Frederick Taylor theory, with the four main principles of Taylorism, where the workers are regarded as machines and their humanity is ignored. Because most of the four main principles of Frederick Taylor, they are focusing how can they will produce more and more, and how can they will help the employees to produce. And they are not looking about their behaviors, their needs, their interests, their motivations, and they are getting like on machines in finally to get more and more mass production. So I want to just tell something about the quality circles. It's very important that we can do a quality circles, but the workers, they should be qualified, they should be well trained. So it's not easy to make a quality circles with a low educated workers, with unqualified or untrained workers. So finally their grouping and their discussions will be not an added value, and even their solutions will be not added value to the company itself. All right. For zero quality control, Chico Chengo. Chico Chengo is also one of Japanese gurus. He's the one that he made this Poka Yoke system. This is what error-proof system. Chico Chengo proposed a method for dropping the defect rate down close to zero using a successive check method. This is the new methods. They start to apply it in Japanese companies. And this method called for workers to inspect each item they receive when they receive it. What's the meaning of this? That I'm working in like a production line with a process flow. So the first process, the person that he is working on this process, on the first process, he need to check his income that's coming to the production. And for the person that's working in the second process, he need to check the output for the process, for the first process. The third process, he need to check also the output. So every process, every person on each his process, when he received the product, he need to inspect it 100%. So finally, I will not have any defects, and finally I will produce a 100% error proof and zero issues at the end of the product itself, right? Chengo gives the example of one television manufacturing company that had a 15% defect rate, and the company was able to reduce it to 6.5% by using quality circles, as we mentioned, and SPC. When the company began to use Chingo successive check methods, the defect rate dropped to 0.016%, which is very, very less defect percent related to the product. Poka Yoke, this is the error-proof methods related to Chingo. Chingo explained that people forgot things and urging production workers to simply pay more attention, as good as asking workers to become God. So definitely they ask the workers to check everything, and maybe we are all humans, so we will have problems. He recommends Poka Yoke, which means mistake proofing or error proofing, the use of a method or device that prevents a mistake from being made or makes a mistake obvious at a glance, therefore attaining zero defects. Poka Yoke, it's another story, so let's move on it because we don't have much time, but it's another successful system. Most of the companies, they are start to using. Management responsibility. In one of his articles, Juran claimed that most quality-related mistakes could be controlled by management. He mentioned, as mentioned, that 90% of issues is coming from management and 10% from employees. And such lack of worker scale or conflicting standards, maybe it can have some errors. He also reviewing the state of quality in different parts of the world and found that US companies had a quality department, quality-related training was lacking for supervisors, and it was often difficult for quality professionals to work with other departments within an organization. It's like a separate section, separate departments, and they don't have much qualifications. That's why they have a problem in the American companies. Taylorism. Juran thought that Taylorism made sense of a time when workers and line supervisors didn't have the skills or education for making decisions. So again, we don't want to put all decisions and authorities for the unskilled workers, so they will start using the Taylorism system. But now planning performance should be recombined in US. He found that Western European companies often had line supervisors with more authority than US supervisors, as well as workers with more skills than US counterparts. But he believes that Eastern European quality was hampered by central planning, centralization, which is have a problem, that protected companies from demands of the market and a lack of competition. In 1969, Juran stated that Japan's quality revolution showed considerable promise for taking Japan to world leadership in the quality arena. So in 1969, this time, the Japan is the first one as a quality all over the world. All right, beginning of the quality crisis in US, right? During, by the way, during this crisis of the US quality, I know that George W. Bush, the father, he went to Japan by himself, and he want to check how can Japan quality products higher than the American products. And when they found some problems on his market, then he started to look about William Edward Demings, and he asked him to go back to US and to teach and train them. And William Edward definitely he went back to US again, and he started to train and teach all of the American companies about his SPC tools and sampling tools. All right. So during the 1970 and early 1980, US automakers could not compete with the quality of their Japanese counterparts. For example, Ford Motor was producing transmission, but was also ordering the exact same transmission from Japan. And transmission made in US were failing far more often than the Japanese transmissions. So Ford engineered dismantled the 2 years of units to determine what the difference were. And the Ford built transmissions were all within the specifications limits. The most important things here that when Ford they start to make the transmission, they are checking or inspecting from some inspection points, which is not the same like Japanese people they are doing. The Japanese people, they have some inspection criteria, more and more focus on the quality rather than Ford motors that they are using on their transmissions. That's why the Japanese transmission is much higher in quality than Ford transmissions. In 1980, Ford finally realized something was afoot in Japan, so members of Ford visited a Japanese assembly plant to see what was going on. The Ford people observed that Mazda could assemble a car comparable to Ford's with only 6% of efforts and far fewer quality problems. Actually, this is because Japanese companies, they start to using a lean manufacturing methods, so they reduce the cost and they make it more efficient with 60% only effort and with a higher quality than the American or European products. Lean manufacturing during 1970 and early 1980, auto industry was not the only manufacturing arena in which the US has a trouble problem. The quality of US consumer also was terrible compared to Japanese products. So many Americans were buying Japanese products, which resulted in US manufacturing companies losing market share and workers losing jobs. In this time, there are a lot of strikes, worker strikes in USA. And as I mentioned, George W. Bush, this time he went to Japan by himself, and he discovered about William Edward Demings, and he invited him to go back to USA to start teach and train the people there. So US television manufacturers accused Japan for using low wages and government subsidies to help Japanese television manufacturers. Zenith Radio Corporation even filed a dumping petition against Japan. So, however, Japanese manufacturers were using lean manufacturing methods to produce televisions, and he's helped them to produce higher quality with lower prices. All right. Lean manufacturing is not the same as quality assurance. It does contribute to quality. Defective parts are identified more quickly because the parts are used soon after they are produced. What is this lean manufacturing? Some companies or some production line, during producing itself, the rejected one or the product that's not meeting the criteria, they recycled or whatever, they reuse it again on the same day of production. So finally, they will not put it in the store, they will not scrap it or whatever, so they can use it and they can make it more and more efficient. So finally, the televisions was 5 times higher than of those made in Japan as a cost of these US televisions. And most consumers don't purchase televisions frequently, so may not have realized the quality difference between Japanese and US. But as Shunan noted, bulk buyers like hotels during this time, nearly 1/3 of US workers in the television manufacturing lost their jobs. Right. Okay, so if Japan can, why can't we? This is the US manufacturers people, they said about their crisis. Right. US discovers quality and quality gurus. Now they start to look about the quality gurus. Crosby published Quality is Free, which helped increase awareness of the need of quality. This was followed by 1980 by Wake Up Call for US industry. And they said, as I mentioned, if Japan can, why can't we? From the series NBC white paper in NBC. And Juran's prediction in 1969 that Japan would lead the world in quality had come true. So his prediction is now true. And US manufacturers were still producing as so they were in a seller's market. But the documentary clearly illustrated that things had changed, and US manufacturers would have to change how they did business. All right, if Japan can, why can't we? Was the tipping point that launched US industries' interest in quality. Juran thought that the documentary set the quality movement back by 5 years and disagreed with the credit it gave to Deming and himself for bringing quality to Japan. So there are men known as gurus in the field of quality, and in USA, Deming, Juran, Crosby are honored with a guru status, as are also Armand Feigenbaum and Walter Shiver. Among the quality gurus in Japan are Ishikawa, Chengo, Genishi Taguchi, which is related to loss function, and Taki Ono. This is the main quality gurus over the world. Deming, William Edwards Deming for PDCA, Philip B. Crosby, Zero, Juran, the Juran Quality Control Handbook, Shiver, also it's related to the zero defect, and Feigenbaum, which also is a German guru, Taguchi, which is related to the loss function, Ishikawa, that's related to the zero quality control defect, and Chigo Chengo, which is related to his main theory of zero defect. Right. Then American Society for Quality Control, as we mentioned, that it's built with Shivert and Deming with Juran, and they drop of the C, which is quality control, control, and they mention as an American Society for Quality, and it's coming this on 1997. Quality and Six Sigma. Six Sigma methodology is used to identify and control variables. And Frank Greiner is the main person that start to make the Six Sigma. Is a collection of managerial and statistical concepts and techniques that focus on reducing variations. And in an interview, also Armand Feigenbaum explained that GE, General Electric, built a quality system around statistical quality control that eventually came to be referred to as a total quality management. And Motorola start to look on this Six Sigma. Also, as I mentioned, a former Motorola employee explains that Motorola developed Six Sigma during 1980 as a survival strategy because it having difficulties competing with Japan. And in Six Sigma for Motorola was just one part of larger transformation. So they are not only building for Six Sigma, but also they are doing a lot of improvements, and as well as cycle time reduction. This is one of the theory for the quality also, cycle time reduction. And finally, they are saving more than $1 billion during 3-year period that was instrumental in company achieving the Malcolm Baldrige National Quality Award. GE also saved more than $1 billion in 1 year using Six Sigma. All right. Quality awards and certification in US during 1980, US industry and federal government, the concern about the low quality in American products and lack of competitiveness. So they want to motivate the companies by building a new prize, what we call a National Quality Award, similar to Japanese Deming Prize. By the way, I didn't mention the Japanese Deming Prize. The Japan, they want to honor William Edward Deming, so they made a prize, and every year they are giving to a best achieving company in the terms of quality. And US people, they start to make a National Quality Award. As a conference were held featuring President Ronald Reagan, Vice President and Bosch, Secretary of Treasury, and whatever. So this is like speakers for the Malcolm Baldrige Quality Award. And during the conference, a report was released calling a National Quality Prize, and then it's having a medal awarded annually by the president. And there are a lot of companies, they start to get these medals, and business leaders, like Michael Douglas Corporation, Ford, and other organizations. And in 1986, legislation was written for the award to be passed to the Congress. And the Baldrige Award is administered by Baldrige Performance Excellence Program. And finally, the award recognized U.S. organization for achievements in quality and performance excellence. All right, by late 1990, the Baldrige U.S. state all based on Baldrige criteria for performance excellence. And Ottawa State University created the Chengo Prize. You remember Chico Chengo, for operational excellence to honor Chico Chengo, the industrial engineer that is working in Nissan, as I mentioned, and thought leader whose management and improvement concepts and technique are fundamentals for Toyota production system. Toyota production system, which is related to Kaizen system, right? The Chengo Prize recognized business excellence, and in 2001, there are 19 different European quality awards, has to be consolidated. So they consolidated in a European Foundation for Quality Management Award, EFQM Excellence Award, which has some similarities to the Baldrige Award. So Baldrige Award is related to USA, EFQM related to Europe, the Deming Prize related to Japan, right? So just only to consolidate. The first quality standards, the industrial standards, were formed in Great Britain in 1901. And in Geneva-based International Organization for Standardization, this is the ISO. They start to publish the quality management system. And in ISO 9000 series of standards had been adapted around the world. And evolution of Six Sigma warns that the creation of 9001, 9000 helped define many of elements of sound quality practice, but it did not assure the product's goodness or fitness. It only addressed consistency in the process. So this is very important. By the way, I put an old logos at 2008. Now we need to put the 2015. So many companies are basically they are building their standards on the 9001, which is not the whole complete quality system. So because they have a lot of drawbacks, and also it's not consistent. It's only given consistency of the process itself. And quality standards in automobile industries, they have also a lot of standards like QS 9000 for telecommunication, TL 9000, and a lot of companies like GM, Ford, and Chrysler, they start to build their standards again in this automotive industries. And one of it is the ISO TS 16949, right? Let's go to the conclusions. Right, quality assurance, quality control, and quality management must be integrated and used together to ensure overall quality. It cannot be as separate functions. SPC, statistical process control, can signal when a process is no longer producing parts in specs, but it doesn't matter if the parts are in specs if the wrong parts are being produced. This is very important, by the way. Quality management provides a system to ensure that such mistakes don't happen. But using a quality management without quality assurance or control is also a mistake, because defective parts can be produced even if the process are functioning properly. Inspection can still play a role in a modern quality. It may be needed to control the manual assembly of unique products, or in situations where there is a danger to life or limb in the event of a failure. However, companies shouldn't rely on inspection exclusively, because as we mentioned, Harold Dodge famously said, you cannot expect quality into a product. Right. The ideal quality system is one that uses quality management to define the process that will ensure that a company is producing what the customer wants and needs. Plan, do, check, act. Quality assurance is used to ensure the product system is working, and quality assurance control management are not standalone concepts. They are overlapping and complementary tools. The modern quality movement brings together ideas from, for example, system analysis, and also the quality movement will from time to time undergo health changes that may be even called by different means. That's it. Thank you.
Okay. Okay.
I know that it's a lot of information on the presentation, and I pass it very quickly, because actually such presentation maybe it needs more time. But anyway, I try to close all of the figures inside the PowerPoint itself.
You've done a remarkable job, actually, Yasser. If you can stop sharing your PowerPoint now.
Yeah, sure.
I didn't tell you, actually, but believe it or not, I did my degree was in quality management. I did a 4-year degree in quality management, and you've basically managed to do in 1 hour the subject matter that I learned in 4 years. So it's been a good refresher for me, because that was 20 odd years ago.
Yeah.
So that's been a good refresher for me. Just one question, sort of related to the food industry. Where did quality, or where does quality, the evolution of quality, sort of fit into the food industry? Have you got any insight into that, Yasser?
Yeah, actually, when they start, as I mentioned, when we start to produce or to have the quality concept, they start on the Hawthorne plant and on the military standard. From the Hawthorne and military standard, they start to get the system through NASA in the HACCP and the hazard analysis and critical control points and whatever. And they look from the military standards, and they take the HACCP from military standard and they start to apply on the food industry. So the HACCP and all of the food quality management system, it came basically from military standards, and also from all of this experience that's happened by Deming and by all of this quality gurus. And my company right now, we are getting making all quality circles, and even the development plans and all of this from Deming. So it's all it's like in one way.
Okay, and obviously quality, the SPC control charts and things like that are very important for your process, having a predictable process in any industry. To prevent defects, safety, food safety, and quality.
Yes, in my company, every day morning at 8:30 o'clock, the production people, they meet like a meeting, and they are having a PowerPoint presentation for all the previous day of the process control, or the control charts, or the defects, or whatever the issues. So all of this is using statistical analysis. Based on it, they start to put a plan to recover it on the same day of production.
Yeah. Just saying then, the next webinar, I don't know if you saw, David Rosenblatt is going to be discussing ISO 9001:2015 and how that can benefit food safety management systems. And yeah, so this has been a good precursor to that. It's really been a good grounding and a refresher in quality systems management, etc. So that'll be good, because that then takes us forward into the future, I suppose. The next,
yeah, definitely.
Yeah, we've not done that by design. It's more luck, but that's great. So, okay, we've gone past the hour. We're 7 minutes past. So I think we'll leave it there. Yasser, thanks very much. I'll talk to you later about Food Safety Live in September. Maybe we can get you to join in with that.
Sure, definitely.
Okay, Yasser.
All right. Okay.
Take care. Thank you very much.
I want to just share information, because most of the people, they think that they are working in the food industry, that okay, now we need to look for the ISO 22, HACCP, SQF, whatever. But believe me, the quality should be one of our main concepts. We cannot work food safety without having a quality foundation and infrastructure. This is a basic. I cannot go through B until I will pass through A. So this is very important. The quality and food safety should be in a one part. It's not only food safety, or it's not only quality.
Yeah,
that's it.
And just to add to that, Yasser, you're perfectly right. And when we talk about quality, let's think of both halves of it, the hard tools, the statistical side, and also the management and the involvement of the people, and let's say quality circles. So fantastic. Right, Yasser, thank you very much. Enjoy your weekend. Good job. Well done.
Thank you.
Okay, ladies and gentlemen, that was great. There was a lot to get through, to be fair, but that PowerPoint, this video and the PowerPoint that we send afterwards will be a great reference tool for you, no doubt. So it's good to have all the content on the slides sometimes. I've loaded in the sidebar your certificate. I've done it slightly different this week. You've been crashing the website all getting your certificate. So hopefully this time it'll work, because I've linked it to Dropbox. Okay, so just to clarify, the webinar with David Rosenblatt, ISO 9001:2015, how that can support and improve our food safety management systems. It's not next week. We've got a week off next week. It's the week after. Okay. We'll be sending the recording, the slides, the certificate by email within 24 hours. So if you can't get it now, you'll get everything within 24 hours. Once again, thanks for joining us today. We look forward to seeing you on the next one. Happy Friday. Enjoy the rest of your day. Have a great weekend, and relax and come back refreshed to fight the good fight next week. Thanks, everyone. Bye.